All right, so now that we've talked a little bit about where complex numbers come from, we're going to dive into the operations of them. So the idea is this: I is equal to the square root of -1, which means that I squared, the opposite, right, would be that I squared is equal to -1. So we're going to write our complex numbers. They're written in this expression, so a plus bi or a minus bi. We put the whole number first, and then we put the imaginary number second. So I acts mostly like a variable. The only situation is when we have I squared, we're going to turn it into -1. So I'm going to treat this just like a variable. I see there's a 2 in parentheses here, so I'm going to distribute that in. Get -6 minus 4i. Still have 2 minus 5i here. I'm going to combine like terms or things that have imaginary parts. So 2 minus 6 would be -4, and then -5i minus 4 more I is 9i. So that would be my solution for number 1. I'm going to go ahead and do the same thing here. Distribute in. You can do number 2 on your own. We'll take a look at number 3. I'm going to distribute in. I get 6 plus 8i. Distribute in the negative, -2 minus 3i. Again, looking for like terms, so 6 minus 2 would be 4, and 8i minus 3i would be positive 5i. You want to make sure that you write it in this order and don't flip it. You don't want to do that because your imaginary numbers or complex numbers are written with the real part first and the imaginary part second. And then we have something that looks like this. You can tell that looks like the box, and it is indeed the box. So we can go ahead and use the box here. 2 minus I, 3 plus 4i. 2 times 3 is 6. 2 times 4i is 8i. Negative I times 3, negative 3i. Negative I times 4i would be negative 4i squared. So I have 6. I'm going to combine these ones here to give me positive 5i, and I have minus 4i squared. Remember that I squared, the definition of I squared is that it's equal to -1. So I'd have -4 times -1 here would make positive 4. Still have the positive 5i and the 6. So I'm going to add 6 and 4 to make 10 plus 5i would be my solution for these ones. Go ahead and take a moment to try number 5 with the box and number 6 with the box as well, and then we'll move into dividing. So when we think about dividing, I'm going to try multiplying these. So just to show you what I mean here, I have 3 minus 2i and 3 plus 2i. So already I'm seeing a pattern. I see that I have the same number here and here, and then this is 2i and 2i, one positive, one negative. So 3 times 3 is 9. 3 times 2i is 6i, times negative 2i is negative 6i, and negative 4i squared. So I can see that these are going to cancel out, and I would have 9 minus 4i squared. I remember that I squared is -1 times -4 would be positive 4 and 9. So I know that the answer is 13. So interesting here that I multiplied two complex numbers together and I got a whole number here. So I'm going to write got an integer. So the reason that this happened is because I multiplied the complex number by what's called its conjugate, its opposite. So when you multiply times its opposite, we get a whole number out. So when we're dividing complex numbers, we have, switch colors here for a sec. We are not allowed to have an imaginary number in the bottom. That is not allowed. And I can't just quite cancel these like this because of this addition sign. And so what I have to do is multiply times its conjugate, 3 minus I, so that I can get a whole number on the bottom. But what I do to the bottom, I must also do to the top. So I'm going to multiply the top here and the bottom here. And that's going to help me to get a solution. So I have the top, I'm going to do 2i, 3 minus I, so 6, negative 2i, 3i, and negative I squared. So this would be 6 plus I minus I squared. 6 plus I minus would be minus, but then the I squared, of course, is turning into a -1. So that means I would have really like a plus 1 here. So this would be like 7 plus I. This would be my numerator, right? My numerator. I'm actually not going to put it in a box there because I don't want people to think that that's actually our answer. So that's my numerator there. And then the bottom, I'm going to do the same thing. So 3 plus I, 3 minus I. Now this is 9, negative 3I, positive 3I, and negative I squared. I know those will cancel. That's good because it's getting rid of that I term. So I have 9 minus I squared turning into negative 1. So 9 plus 1 would be 10. This is my denominator. So when I write this as a fraction for my final answer, I'm going to put my numerator, 7 plus I over 10. If there was anything, I would simplify it, but there isn't here. So I have my solution there. Cool. So go ahead and pause your video and try this one. In a second, I'll try it here because dividing can be hard. Cool. So I'm going to multiply times 2 plus 2i. That's my conjugate, right? The opposite. Same exact letters in the same order, but with a positive instead of a negative. So then we'll do the same on top. 2i. So my numerator just gets distributed in. So this would be 6 plus 6i. And then my denominator, I'm going to do using the box. So 2 minus 2i, 2 plus 2i. This is 4, 4i, negative 4i, negative 4i squared. So these will cancel. 4 minus 4 times I squared. I squared, remember, is negative 1. So this would be 4 plus 4, which is 8. So my denominator here is 8. And then I'm just going to see if there's anything I can simplify, which I can. I can divide each of these by 2. So this would become a 3, and a 4. So my final answer would be 3 plus 3i over 4. That would be my simplified answer. Ask tons of questions, guys. This can be hard, so let me know if you need anything. Thanks. Bye.